Okay, so we're just looking at the day 2 notes, so a little bit of quick review. The domain of a function is the set of all possible input values. And input means domain is x, is typically the variable that goes with it, but it's the input. Range is the set of all possible output values, and usually that is y. Okay, so let's look at some examples here. You can use your notes that we did yesterday with the highlighters. I'd really recommend that strategy. And then you can also use your foldable as needed. So on example A, some quick review is if it's just a set of points, I recommend going ahead and making an input-output table, vertical or horizontal, it doesn't really matter. So if you go ahead and you write down this point right here is -3, -2. This point is -1, 0. This is 1, 2. Sorry, I had to think about that. This is 3, 4. So those are all of our points. So when it is a set of points, your domain, you're going to write in these braces right here, and it's your x values. We typically list them off in order from least to greatest, and if there are any repeats, we don't write down the repeat. So those are all of our x values. And our range is all of our y values. Put them in braces, and we go in order from least to greatest. Okay, so go ahead and see if you can find the domain and range of example 3b. All right, so I would have listed off my points, and I'm going to try it in a horizontal table just to show you it can go either way. So this point is -2, 4. This point is -1, 2. A lot of people miss this point down here, but there is a point there at 0, 0. And then this is at 1, 2. And this final point is at 2, 4. So your domain would be -2, -1, 0, 1, 2. And your range, remember, we do not repeat the values. So we have 4 is repeated, 2 is repeated, and 0 is by itself. So those are the only ones we need to list off, and we typically list them off in least to greatest. Okay, so now let's go ahead and let's try to find the domain and range of example 3c. So I'm going to use my highlighter. So I have, it runs left to right. The farthest left point is right there, and the farthest right point is there. So domain is left to right or horizontal. So that is from -2 all the way over to 3. And it does touch at both -2 and 3. So the domain is -2 is less than or equal to x is less than or equal to 3. Okay, now let's look at the range. So the range is how far it goes up and down. So its lowest point is here at -1. And its highest point is here at 2. And it does touch both -1 and 2. It has closed circles. So our range is y, and it's going to be from -1, less than or equal to y, is less than or equal to 2. Okay, go ahead and find the domain and the range for example 3d. All right, so the domain, if we look at it, that is from left to right. So the farthest left point this graph reaches is right here. That's at 1. And then the farthest right point the graph reaches, the farthest it goes to the right is right here. That's at 5. It does touch both. So our domain is x is less than, oops, I'm sorry, screwed that up. Our domain is 1 is less than or equal to x is less than or equal to 5. It's compound inequality. All right, let's look at our range. Our range is how high and how low it goes. So the lowest it goes is right here, which is at 0. Now notice there are no arrows at the top, so it does not extend up forever. So its highest point it goes is right here, which is at 4. So it goes from 0 to 4, and it does touch both, so we're going to use less than or equal to symbols. So 0 is less than or equal to y is less than or equal to 4. Okay. Before we do example 4, I want to go look at your foldable. In your foldable, when you open it up, the center column says independent and dependent variables. So An independent variable is the input, okay, which is typically x. It can be any value in the domain. The dependent variable is the output, which is typically y. It can be different letters, but a lot of times we see x's and y's. But it depends on what the independent is. So let's look at an example for it to make more sense. So I will tell you, you'll see this wording sometimes. Y is a function of x. When they state that, it means y depends on x. So in this case, the y value is the dependent and the x value is the independent. All right, let's look at this example. The function c equals 6t plus 8 represents the cost c. So c is the cost for t-shirts. So t is the number of t-shirts you buy. Plus shipping. So $8, the plus 8 is $8 in shipping. So what are the independent and dependent variables? All right, well, if you think about it, the cost of your order, how much money you have to pay, depends on the number of t-shirts you buy. So cost depends. That means cost, which is C, is dependent. And so that means that T, the number of t-shirts, is independent. Because if you kind of think about it, for example, sometimes we see the number of items in your grocery cart and cost. Well, the more items you put in, the cost goes up. You can't add an item to your grocery cart and have cost change, or have cost stay the same. So if you add items, your cost will increase. That means your cost depends on how many items you buy. We'll see some different examples as we continue. All right, let's go back into our notes. So let's look at example 4 together. All right, example 4 says, the function y equals negative 3x plus 12 represents the amount y in fluid ounces of juice remaining. So y is the amount of juice remaining. It's always helpful to write out what your variables represent. In any type of a word problem, it will make your life so much easier. It's a good practice to get into, and I promise it will help you improve at word problems. So y is the amount of juice remaining in a bottle after you take. X is the number of gulps you take. So the independent variable is x. So independent is x, which is number of gulps. And dependent is going to be y, which is amount of juice, because if you take 1 gulp or 5 gulps, that's going to majorly change how much juice is in the bottle. So the amount of juice in the bottle depends on how many gulps you've taken. Okay, now the domain is 0, 1, 2, 3, and 4. So that's 0, 1, 2, 3, 4. Now you can use a calculator to plug into this equation, and you want to find the numbers. So like when you plug in 0, you have 12. When you plug in 1, you have 9, and so on. So let's just kind of finish this up real quick. So you'd have 6, and then 3, and then 0. Okay, so that means that your range is your y values, and you have, I'm going to go ahead and put them in numerical order, but 0, 3, 6, 9, and 12. Okay, let's go ahead and do one more. So example 5, the function a equals negative 4b plus 14. So there's our function. Represents the number of avocados. So a is the number of avocados it says you have left. Avocados, struggling here. All right, you have left. After making B batches of guacamole. So B is the number of batches of guacamole that you made. Okay, so we're going to identify independent and dependent variables. So if you make 1 batch versus 5 batches, all right, that's going to change how many avocados are left on your counter. So I would say that if we kind of write it out here, the number of avocados you have left, I'm just going to put avocados, So the number of avocados left depends on the number of batches you make. So if you make more batches, you have less avocados. So that means avocados is dependent. So A is dependent on B. So B is independent. So avocados, the number you have left depends on how many batches you make. That's why avocados is dependent. Okay, so when it asks you for domain, so in this case, B is the number of batches. So if you make no batches, 1 batch, 2 batches, or 3 batches. So if we plug it in to our function that we put in a box at first, so we would have 14. So that means if we make no batches, we have 14 avocados. So that must be how many we started with. Now if we plug in 1, we have 10 avocados. If we plug in 2, then we have 6 avocados. And if we plug in 3, then we would now have 2 avocados remaining. So what would your range be? All right, your range would be 2, 6, 10, and 14. And that is the varying number of avocados you have as they go through and make more batches. You start with 14, it goes down 4 every time. That must be how many avocados the recipe requires. So by the time you get through 3 batches, you're down to 2 avocados. And we're not looking at making half batches, so you can't make a 4th batch because you don't have 4 avocados remaining.